What's up, math scholars? Mrs. Harp here. I'm going to record 2 videos to go along with this study guide, one for the first half and one for the second half. And so our goal in this video is get done with 1 through 6, okay? And I'll be gone tomorrow, so I'll see everybody back on Thursday. So let's start with number 1. We are given a sine value, and we're given a little bit of information on where theta lives. Let's talk about theta first. Bring them over here. Theta lives between 3 pi over 2 and 2 pi. Can somebody tell me what quadrant that would be in? Ashley? Quadrant 4. Perfect. I'll give you a ticket for that. Do you still need tickets or not? Yeah, if you guys are wondering how many tickets you can still use, 4 on this Friday's quiz and 4 on your exam. I know some people are taking it. Okay. So quadrant 4 does tell us that we are in a positive negative quadrant, which means cosine is positive and sine is negative. Now sine is provided and it is negative as expected, but cosine we will find ourselves. Do you know what drove me a little bit crazy when I did this problem last period? That negative 8 over 10 is not reduced. So let's reduce it to start. How would negative 8 over 10 reduce down? Negative 4 over 5. Perfect. That'll just make our calculations a little bit easier to work with. Once you have sine, you actually can get cosecant right away, because sine and cosecant are reciprocal, so that would be negative 5 over 4. If you forgot who is reciprocal with who, it would be on that little sheet that we taped in on day 10.3. Okay, anytime you have sine and you're looking for cosine, or vice versa, you want to do the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. We're going to plop that negative 4/5 in for sine theta and square it. Negative 4 squared is a positive 16. 5 squared is a 25. And then, do you remember what happens next? We've done a few of these in the last week. You should know by now. Subtract it over. Very good. I have to find my calculator. Ah, here it is. So it's 1 minus 16 over 25. And then you can hit math enter to refraction that answer. It should be 9 over 25, but go ahead and check that. What step happens next? Square root. And normally, square roots give you positive and negative answers, but we discussed, thanks to Ashley, that we are in quadrant 4, so our cosine value is going to be a positive 3/5. Positive 3/5. I'm sorry I did not give you much workspace on the study guide. If you need a separate sheet, go for it. On the actual quiz itself, I doubled the amount of workspace for every problem, so it will be on 4 pages, like stapled together. So you'll get the quiz on Friday, and it'll be these multiple pages stapled, and you'll probably have a heart attack, but it's just because I gave you more workspace. So workspace is a good thing. It won't be any longer than the study guide, though. All right, what did we just get? Cosine? So we now know secant, because cosine and secant are reciprocals. That's nice. We need to get tangent. What do you guys know about tangent? Tangent is sine over cosine. So we'll just take our answer for sine, negative 4/5, and we'll divide it by our answer for cosine, 3/5. Looks like those 5's will just cancel out probably, huh? So I believe tangent is negative 4/3. Which means you'll have cotangent by reciprocaling it. So I'll pause and let you catch up and ask questions. Alrighty, number 2. We are going to now be simplifying using properties on that 10.3 sheet. If you're wondering what that sheet says at the top, if you're looking for it, it says fundamental trigonometric identities. So fundamental trigonometric identities. It's the biggest one we taped in of the 3. So the first one we're going to use is going to be the tangent negative x. See if you can find that on your sheet anywhere. It's like a seek and find. Found it. Where did Madison find it?
Is it the one that says tan beta equals sine beta over cos beta?
Close. We want to look where there's negative. See how you have that negative inside the parentheses? Look for that.
Oh, is it tan pi over 2 minus beta equals cot?
Getting closer. It's one below there.
Oh no, it's tan.
She found it. It's under negative angle identities. So we are basically going to replace that tan negative x with a negative tan x.
Sorry.
You guys okay with the first replacement? So that's replacement number 1. All right. Replacement number 2, we're going to replace tangent with something that he is equal to. Now, tangent you can find in a couple of places. The one we're going to use is the one under tangent and cotangent identities. So we're going to replace tangent with sine over cosine. That's the last replacement because everything's going to kind of cancel now. Watch what's going to happen. I love these. Ready? Cosine. Cancel, cancel. And double negatives make a positive. So our final answer is positive sine x. All right, hello everyone. You might be wondering why we're on a blank slide right now. We need to discuss real briefly the Pythagorean identity. It's the identity that we've used more often than any other identity in this chapter. Now, we had a day where we discussed that you don't necessarily have to use the identities the way they appear. You can rearrange them. Do you remember that day? And we arranged this like literally 5 different ways. So I know one rearrangement we did was we subtracted this cosine squared x to the other side. Remember that? I know another rearrangement we did was we subtracted the sine squared x to the other side. So just be aware you're allowed to subtract things to wherever you want to subtract them, and you can still use the identity. Okay? So I want to rearrange it in this manner for the next problem we're about to do, number 3. I want to take the original, and subtract this 1 to the left-hand side. That would give me sine squared theta minus 1. And I want to subtract the cosine squared theta to the right-hand side. That would give me negative cosine squared theta. Did you follow who I subtracted where? So I brought my 1 to the left with subtraction. I sent my cosine to the right with subtraction. And this identity is the one we're about to use in number 3. Okay. Write it down somewhere. Maybe even write it down the margin beside number 3. All right, we're on number 3 now. We had that brief intermission just to kind of discuss how we could rearrange the Pythagorean identity because of this first replacement I'm going to perform. What do you think I'm going to perform with that pink one right there? Sine squared x minus 1. What does sine squared x minus 1 equal based on what we saw in the previous slide? Negative cosine squared x. Very good. Now, just a refresher on how to do these verifying problems. You do verifying problems by only working on the left-hand side and trying to make your left-hand side match your right-hand side. Once your left-hand side matches your right-hand side, you'll be done. It's kind of like a little proof. All right, my next replacement is going to be with this cotangent right here that I just put the brackets around. So can you guys look up what cotangent equals, please? It does equal 1 over tangent, but I want the other option. Cosine over sine. So I'm going to do cosine squared x over sine squared x just because it's a squared scenario of the cotangent. So this cotangent just got replaced by cosine squared x over sine squared x. I guess I could use parentheses around that if I wanted to. I'm still not working on that right-hand side. I'm only working on the left-hand side. I have a little scenario here where I'm dividing by a fraction, so you all remember what to do there, right? Multiply by the reciprocal. So somebody's going to cancel. I heard people getting excited. Their stuff going to cancel. Guess who? The cosines. So my final answer is negative sine squared x and negative sine squared x. Verified. Put a big check mark because you just verified your left-hand side matches your right. We are on number 4. Doing good on time. What do you guys think we should replace first? We're only working on our left. We're doing left replacements to try to match our right. Here's a hint. Can you find that guy on your sheet? Sine pi over 2 minus x. Sine pi over 2.
What sheet are we talking about?
Oh, this is the 10.3 fundamental trig identity.
So the same as this? Okay.
Yeah. We're still on the same sheet. Did you guys find it? Look under co-function identities. Yep, it equals cosine. Thanks, Ashley. So it equals cosine. Why don't we go ahead and replace tangent in the same step? So look on your paper for something about tangent that maybe might be helpful at this point. What did Lexi whisper? Perfect. Sine over cosine. I know you never know when I want you to blurt because I have this big sign, no math blurting, but sometimes I actually do want you to blurt. All right. So we're in a really good spot, guys. Guess what we can do? Cancel our cosines. Cosines are gone. Sine x on the left. Sine x on the right. Check mark. We're verified. We're good to go. That was an easy one. We're now solving. They did say we're solving in this interval, 0 to 2 pi, so we really only have to look around that unit circle once. We don't have to add that 2 pi n tagline on things. So we're solving. Here goes. Let's add that 1 to the other side first. You can't see that at home on the video, but the whole entire board is like shaking. That was weird. Divide by 4. Yeah, well, somebody slammed their locker, which didn't shake the board bad, but it was like an aftershock, because then the board started shaking. All right, so sine squared x is 1/4. We're going to finish it off with a square root. Now remember, whenever you do square roots in math, you go with the plus or minus out front. The square root of 1 is 1. The square root of 4 is 2. Who knows what time it is?
Unit circle time.
It's unit circle time. It's unit circle
And
time.
it's 10:50.
What?
And it's 10:50.
And it's 10:50. So we're heading to our unit circle. We're going to look for all sign values, which are y values, of positive or negative 1/2. There's 4 answers. I'll just tell you now. You're looking for all 4 of them. So let's look in quadrant 1. Do you see any y values of positive or negative 1/2? You should, at 30 degrees, or pi over 6. And then we can just kind of reflect around. At 150, or 5 pi over 6, is another place that has a sign value of 1/2. Keep reflecting. Down at 210, or 7 pi over 6, there's another y value of negative 1/2. And then the last one, 11 pi over 6. Alrighty, our last one we're going to do on this video today. It's going to be a zero product property that we'll be utilizing on our solving journey. So we're going to be looking for a common monomial, a common factor that we could pull out of both terms. Do you know what it is? Sine x. Very good. You are paying attention. That makes me so proud. Sometimes. Hee hee, she's giggling. Okay, so after I pull a sine x from the first term, I'm left with a 2 sine x. But what would my second term be left with if I removed a sine x? A negative 1. And then this is classic zero product property. If sine x times 2 sine x minus 1 equals 0, then we can conclude that one of the two must have been 0. So, conclusion, either sine x equals 0 or 2 sine x minus 1 equals 0. So these are the ones where you do get a lot of solutions. You can get up towards like even 8 solutions to these. I don't remember how many solutions this one has, but it's a lot. So this first branch, sine x equals 0, it's now unit circle time. So we look for all places that have a y value of 0. And we're only going the first spin around the unit circle. So anybody see any places that have y values of 0? 2 pi, somebody said. Pi and 0. And I listed 0 and 2 pi as separate guys, even though they live at the same place, because it did say to solve over the interval 0 through 2 pi. So technically those are different places. One's at 0 degrees, one's at 360 degrees. They're the same location, but they're different values. All right, and then over here, add 1 to both sides. divide by 2 on both sides, and then look at your unit circle. Where are all my sine values of 1/2? I feel like we just looked for 2 of them. Well, there's only 2. Where are all our sine values of 1/2? All of our y values of 1/2. Uh-huh. Perfect. Yep. Who was saying that?
Emma.
Oh, Emma. You can have a ticket, Emma. I thought it was Ashley again. I'm like, Ashley got fired. What was it? Here you go. Hey, thanks for watching the video, everybody. That's the first half. I'll be recording a second video that you'll be watching with the sub, and I know there's been people in and out, absence and field trips, and I'm going to be gone tomorrow, so hopefully through these videos we can all get reviewed for the quiz. Quiz. It's a quiz. It's a quiz. Goodbye.